All right, good morning. Just to save some time in class, I wanted to make a video of our 7-4 practice that you could refer to even overnight if you need to. Tomorrow and on the 2nd of February, we're going to have a quiz over sections 7.3 and 7.4. We've talked about this in class. We'll do a little bit of review after we go over this 7.4 today. One of the first things, I'm going to switch papers here in a minute, but one of the first things that we do with these drawings is just put in all the different information that we can assume. And in the case of this rhombus, we know that diagonals bisect each other, so I was able to move those measures there. In a rhombus also, angles are bisected, so I know that if this angle is 67, so is this one. That makes these two angles split up at C 67. And then if I actually put them together here, that makes the large angle at C 134 degrees, large angle at A 134 degrees. To get what the large angle is at D, we know that next to or consecutive angles are supplements. They add to 180. If I do 180 minus 134, that tells me that this entire angle here is going to be 46 degrees. And if I split it up, 23 and 23. So going through the process of filling in everything you can about this figure. Oh, and also I know that rhombus diagonals intersect at 90 degrees. So having that lets us go into answering the questions. And I actually, for the questions, I'm going to move to another page. I had highlighted in yellow, the very first one is the measure of angle AED, it's in yellow, and that's going to be a 90-degree angle. It's at the intersection of the diagonals. In a rhombus, the diagonals intersect at a right angle. ADE is in green. That's going to be the smaller angle, half of this angle D, so that's a 23 degrees like we had there. And here we got a BAE, our Bay angle, BAE. It actually extends past up to C. That's going to be one of those 67-degree angles, half of the 134. The length of A to E is this part of is half of this short diagonal, it's 5. And the length of B to E, it's half of this other diagonal, it's 12. Now, in 6 and 7, we had a drawing on our page that actually, if this is rectangle JKLM, this is all about setting the diagonal lengths equal to each other. JL is a diagonal, KM is a diagonal. There was an example like this in your book that I had led you to. I think it was example, where'd my paper go? So I'm setting these two equal to each other. This was example 5 on page 391. And I'm going to solve for x by starting and taking 3x away from both sides. If you started a different way, no problem. 3x plus 4, 4x minus 1. When I add 1 to both sides, I'm going to find out for this problem that x is 5. Now, it also wants the diagonals lengths. And so I'm going to go back in and say then that JL is 3 times, not just solve for x, find the lengths. JL is 3 times 5, which is 15 plus 4. I'm going to make it 19. If my problem's solved correctly, KM should work out to be 19 as well. 4 times 5 is 20, minus 1, that's 19 as well. Just make sure you're following the directions. It's not just solve for x. In 7, 2x minus 6 equals, a lot of people were asking me about this 3/2. I'm just going to put it as 1.5, 1.5x plus 1. If I subtract 1.5x from both sides, don't let those fractions throw you for a loop. It's a half of x minus 6 equals 1. Add 6 to both sides. Half of x equals 7. This kind of threw some people for a loop too. When I divide by 7, how many halves go into 7? The answer is 14. I want you to think about this. If I had $7, how many sets of 50 cents would I have? So there's that 14. 7 divided in half. How many halves go into it? 14. Now, I had graphed 8 and 9 ahead of time. Told you had to do some work with distances and slopes and whatnot. It appears that this figure right here is a rectangle. So I need to just go in and say, all right, if it's a rectangle, what do I need to show to prove that it's a rectangle? And I'm going back into my notes right now. And the basic definition of a rectangle is, where am I at here? A parallelogram with 4 right angles. So do I want to go and find slopes for right angles here? I could, but at the same time, I think I could take the approach of some parallelogram. Every rectangle is a parallelogram. ZW is equal to 1, 2, 3, 4, 5, 6, 7, 8. YX is equal to 1, 2, 3, 4, 5, 6, 7, 8. So this pair of opposite sides is congruent. WX is 1, 2, 3. ZY is 1, 2, 3. So I can mark these. Do I expect to see the lengths written? I absolutely do. Right now, I'm onto a rectangle that I've got a parallelogram right now. Opposite sides are congruent to each other. I'm also going to say this. Horizontal lines are parallel. And so are vertical lines. Now, so far, vertical lines are parallel. So far, I've gotten a few things going on in regards to it's a parallelogram. But if I want to prove it's a rectangle, I got to go do some slopes. If you did slopes, we've got vertical lines have a slope of, vertical lines have no slope, and horizontal lines have a slope of 0. So the opposite reciprocal proof isn't going to help me here. But I do look at one theorem, and I want you to add this to your paper because I don't think this was one that got used pretty regularly. Theorem 713 says a parallelogram is a rectangle if and only if its diagonals are congruent. So knowing what I know here, that I've got parallelogram, if I go and calculate its diagonals and show they're the same, that's enough to show it's a rectangle. And in talking with some kids in 7th hour, they like using the distance formula better. So the diagonals are ZX and YW. I'll get YW over here. I just want to show that they're the same. Z to X. Add this to your paper if you don't have it. And again, keep in mind, this is part of what could show a Z to X, 3 and -2. I've got how far apart is 3, how far apart is 8. The square root of 8 squared plus 3 squared is going to give me 64 plus 9. It's going to be the square root of 73. Now, let me go, let's see how far apart. So I got YW now. YW, squishing this up in here. YW is -5 and -2. If you're wondering, do I have to do all this work? Yeah, you do. 3 and 1. We're trying to show how far apart is 3, how far apart over here is 8. So guess what? I just showed that those diagonals are congruent. So since the diagonals are congruent and it's already a parallelogram, we are for sure that number 8 is a rectangle. Now, number 9 is appearing to be a square. And for the square, only if it's a rhombus and a rectangle. So we need all the sides the same. And actually, we could do opposite reciprocals for slopes, but let's first go through and pull side lengths for everything. X to W. Oops, that's not what I wanted to do. For each of these, I'm actually going to just see X to W. I'm going to take a look at, I'm still writing the wrong thing. It's early morning before school starts. X to W, X, Y. There we go. X to W. How long is that one? 1, 4, 4, 1. How far apart? 3. How far apart? 3. I'm going to go in and see if all the rest of them have the same how far aparts. I know it sounds funny like that, but I know my kids are following. Y to Z, Y to Z, or I'm sorry, W to Z, W to Z, 4, 1, Z, 1, -2. How far apart? 3. How far apart? 3. Okay, so I know those two sides are congruent to each other. Their length would actually be square root of 18. Square root of 3 squared plus 3 squared. So I've got that. Let me go see if where am I at? ZY. Do you need to show it all? You do. ZY, 1, -2. Y is -2 and 1. How far apart? 3 and 3. There we are again. That's square root 18. And then Y to X. So we're showing right now it's a rhombus, and it also has to be a rectangle. Rhombuses have all 4 sides the same. It's Y to X. 1, 4. How far apart? 3. How far apart? 3. Yep. We got square root of 18 for all the side lengths. My mathematics is there. And then actually, after doing number 8, a square is a rectangle and a rhombus. I'm actually looking at what I had done in the other one. Are the diagonals congruent? And I like this method because all I got to do is count. If I can, let's see, these diagonals, 1, 2, 3, 4, 5, 6. So WY is 6, and I do believe 1, 2, 3, 4, 5, 6. That's congruent to XC. Those are both 6 units long. That equals 6, this equals 6. Those are congruent. All right, so since we can call this a square, because all sides the same, which makes it a rhombus, and diagonals are equal, which makes it a rectangle. And a quadrilateral is a square if and only if it's a rhombus and a rectangle. Again, you could have used slopes. Do you have to go through the process of proving it all? You absolutely do. When I look at the back side of this, I had a paper that just sort of cleared up how you wanted to approach this. As I said in class, the answers to all of these is yes. Yes, it's a rectangle. Yes, it's a rhombus. Yes, it's a square. The question is, how do we go and explain this? Well, I'm going to use the definition of a rectangle. A rectangle is a parallelogram with 4 right angles. First of all, I need to say that, is it a parallelogram? It's a parallelogram because I have opposite sides. Let's see. Parallelogram, I have opposite sides congruent. That's one of those methods. And then it becomes a rectangle because it's got the 4 right angles. A parallelogram with 4 right angles. So that makes it a rectangle. It is a parallelogram, and then it's a rectangle because it's got 4 right angles. Is it a rhombus? A rhombus is a parallelogram with 4 congruent sides. We have that true. This is a parallelogram. I said it in number 1. Opposite sides are congruent with 4 congruent sides. You guys have gotten a lot better this year in terms of explaining yourself. Determine whether quadrilateral is a square. You got it. We've got 4 right angles and 4, we have, it's a square because it has 4 right angles and 4 congruent sides. 4 right angles, and it's a rhombus. I'm going to say that. It has 4 right angles. And we already said it's a rhombus. As long as it has 4 right angles and the characteristics of a rhombus, it's a square. Now, we've got some measures of angles here. Find the measure of AEB. Well, since this is a rhombus, AEB is going to be 90 degrees. And then next question says, find the measure of angle EAD. Well, since it's a rhombus, EAD would be 45 because that's 90 divided by 2. We know it's a rhombus, and rhombus's theorem, rhombus opposite angles theorem. Since it's a rhombus, each diagonal bisects the angles, so that last one is 45. Good luck with your review and quiz.